We now discuss the sensitivity analysis regarding the changes in objective function coefficient. There are three related concepts. The first one is allowable increase, second one is allowable decrease, and the third one is range of optimality. The allowable increase refers to how much we can increase from the current objective function coefficient. Allowable decrease means how much we can decrease from current objective function coefficient. The values in the allowable increase and allowable decrease indicate the amount by which an objective function coefficient can change without changing the optimal solution, by assuming everything else will be the same. The range of optimality is the combination of the allowable increase and allowable decrease. Now let's look at this LP model. In this example, we are going to maximize 350x1 plus 300x2. We might wonder how much we can change the coefficient, for example, the 350 for the x1, so that we still have the same optimal solution. We can replace 350 with a C1, and now we wonder how much C1 can change from 350 to the upper bound or to the lower bound, and we still have the same optimal solution. From the lower bound to the upper bound will be the range of optimality. And from the current 350 to the upper bound will be the allowable increase. From the current value of 350 to the lower bound will be the allowable decrease. Actually, we can use a graph approach to demonstrate the allowable increase and allowable decrease. In this LP model, we have the 350 times x1 plus 300 times x2. Our current optimal solution is 122 for x1 and 78 for x2. The total profit for this model is 66,100. Now we are going to assume everything else will be the same, especially for these constraints, and we are going to change the coefficient of x1. For example, we can increase 350 by 5 every time, and you can notice the level line of the objective function over here will change right after we change the coefficient. So if I keep changing, you can see that the level line of the objective function is changing as well. And we are now at 390, and if we keep increasing, you are going to see that the level line is approaching one of the constraints, the labor constraint right now. And when we reach 450, we realize that we have multiple optimal solutions right here. So we touch the upper bound of the coefficient of the x1. If we decrease the value of 350 to a certain number, in this case will be 300. If we decrease further more than 50 from the 350 to be below 300, we are beyond the boundary of the allowable decrease. So at this point, we touch the lower bound, the 300, for the allowable decrease of the coefficient of x1. So you can see that from 300 to 450 will be the range of optimality for this LP model. Actually, after we run the Excel solver, we can obtain a table we call the sensitive tables for the decision variables. In this case, you have x1 and x2, and we know that the optimal solution for x1 is 122. The optimal solution for x2 is 78. If we keep looking at the x1, we find that the current coefficient value is 350, and we have an allowable increase of 100 for x1, and allowable decrease of 50 for x1. So this 100 is the allowable increase for the coefficient of x1, and this 50 is the allowable decrease for the coefficient of x1. Similarly, we have current coefficient for x2 is 300, and the allowable increase for x2 will be 50. The allowable decrease for x2 will be 60.67. And together, the range of allowable increase and allowable decrease will be the range of optimality. Similarly, for x1, the allowable increase and allowable decrease from 300 to 450 will be the range of optimality for x1. In this table, you can also notice a term called reduced cost. In this table, we have 0 and 0 for both x1 and x2 for the reduced cost. It means the marginal profits of x1 and x2 are sufficiently high so that we do not have to reduce the cost for x1 and x2. And as we can see, we do produce 122 for x1 and we produce 78 for x2. It means we are already producing x1 and x2 so that we do not need to reduce the cost for x1 and x2. Thank you.